Hi, good morning. It's me, Tim Dodd, the Everyday Astronaut. That's the first thing I've said this morning. Oh, whoops. How are you guys? It feels like it's been just about forever since we've actually had a live rocket launch to watch. So I'm really excited to finally be able to live stream something and see something fly. It's been a couple months, which feels like forever. Granted, Rocket Lab just launched a couple weeks ago, but I had just finished up that Aerospike video, and I was like, maybe I need a little break. Maybe I need to not just like work constantly. So, hi guys, how is everyone? Welcome to my coverage of a Cygnus capsule launching on top of an Antares rocket, heading up to the International Space Station for NASA. So, friendly reminder here. So this is going to be a funny friendly reminder. So normally I would urge you to go to everydayastronaut.com/pre-launch previews, and you'd be able to click on an article version that would give you the full rundown on everything. Unfortunately, I didn't have time to finish this up, and John, who normally helps us, has been very busy lately. So I think I'm working on, in our Discord, we're going to find a few new people to help write articles so that we always have them up to date. But normally that's the best way to just be able to check on all the information. But really, we can still get most of the information we need. This launch is going to be happening in 28 minutes. Ooh, I wonder if it's been a while since the countdown. I do still have the countdown clock. Hold on, watch this. 1 second. There we go. Oh, I'm going to put this baby over. No, I'm going to switch this around. Sorry, it's been so long since I've done a live stream. I don't even remember how to run anything here. So, yeah, we're 27 minutes away from NASA and Northrop Grumman launching a vehicle to the International Space Station. And since I don't have anything up, I'm going to just give you guys a rundown on the Antares. The Antares is a really unique vehicle. It's really small, or at least it's really short. It's about the exact same width as a Falcon 9, but the entire rocket is actually shorter than just the first stage of the Falcon 9. And maybe it's not that the Antares is really short. It's more just the Falcon 9 is really, really, really tall. Like, for how skinny it is, the Falcon 9 is the longest and skinniest rocket. But it's interesting to me that both of the commercial crew providers, or commercial contract providers, the commercial resupply people, both have like the same diameter rocket. One's just like almost twice as tall as the other. But anyway, this is the Antares rocket. It's kind of backwards from a lot of rockets, where the first stage is liquid fueled, and it used to run on basically NK-33s, which were remade by Aerojet Rocketdyne as the AJ-26. And then now they switched those engines because they had a failure about 4 or 5 years ago now, and so they switched it to using now. They're using it's not actually an NK-33 variant, but it's the RD-181 or the /RD-190. They're basically the same thing. So the way that works is Energomesh in Russia makes the RD-170, which is a 4-chambered version of a closed cycle engine, and it takes some of the heritage, especially in the closed cycle loop and things like that, from the NK-33, the engine that was supposed to power the N-1 moon rocket and the NK-15. And it has kind of some of the similar technologies, especially considering its fuel, or its oxygen-rich closed cycle, which is really cool. That's something that only to date Russia's ever actually really flown. The Blue Origin's BE-4 will also have a oxygen-rich closed cycle. If you don't know what I'm talking about, definitely, that Raptor video that I produced that's like 50 minutes long, check that out, because I go through all of the cycle types and help you understand fuel-rich, oxygen-rich, the pros, the cons, and all the different things of all the different cycles. But hopefully, some of you guys, at least, if you're listening, hopefully you have a decent idea what I'm talking about. If not, basically, it's the fuel pumps that pump the engine, what they run on, and how they run and how they operate. So Northrop Grumman, well, it used to be Orbital ATK, switched to the RD-181, which is a single chamber version of the it's a single chamber version of the dual chamber version of the RD-180, which is a dual chamber version of the quad chamber version of the RD-170. Are you confused yet? And it all stems from the heritage of the NK-33. Come on, guys. Yeah, this stuff is kind of hard. I need to do a video rundown on the lineage of Russian engines, because that's probably what I'll do very, very soon, because it is very confusing, and there are a lot of them, and they're all very, very good, very, very good engines, still arguably some of the best engines ever made. Yeah. So that's that's the first stage. Sorry, wow, this is like quite the pre-launch preview here. The first stage of this vehicle is powered by two RD-180s. So basically, they're NK-33 drop-in replacements. So very similar. Then the second and third stages are both solid rocket boosters, which is quite unusual for an upper stage to be a solid rocket booster. Why don't I move my face so you don't see that? And also, you just can barely even read the text. What am I doing over here? So yeah, that's what's going on. They're going to launch the Space Keg today, which is the Cygnus Capsule. This thing is a very voluminous. Is that the right word? Sounds interesting. Voluminous. It's a very large interior cargo. It only has it has no vacuum section. Like the Dragon trunk has, the what am I thinking of? Open, not sealed version. Then it has pressurized and unpressurized. Jeez. I think I need to get to some coffee. So it's pressurized only. There's no unpressurized version. But this the Cygnus capsule is actually being looked at in a proposal for the Artemis missions. The first humans to go back to the moon since the Apollo with NASA is the Artemis program. We're hearing a lot about it. One of the proposals is with Blue Origin and basically Lockheed Martin and Orbital. And Orbital would make like a space tug that would do some orbital maneuvering for the descent stage and stuff like that. Yeah, there you go. That's the stuff. And then today we're gonna be launching NG-12, and I'm really excited about it. I have not seen a new Northrop Grumman launch like this in quite a while. So yeah, should we just let's go ahead and tune in here. I've got this all pulled up. Look at this. NASA already had. Oh, wait, it does have unpressurized cargo. Oh yeah, like CubeSats. It has a tiny bit of like room right there on this part. So, yeah, there it is on the pad. I'm thinking, let's listen in for a little bit here. Real quick, I need to say hi to Technical Fool. Thank you. Innocent Raptor, how's it going? Nice meeting you in Europe. Hector, how's it going? Tyler, awesome. Thank you guys for tuning in this morning. And what did Tyler say? Tyler's at Wallops in Virginia, watching it from the road. Keep doing what you do. Thank you. And thank you guys are all tuning in. So, all right, let's go ahead and listen in here. I'm curious to make sure we have any updates, and let's do some listening.
Enabled ME1 and ME2, TVC and AHA buses.
LCAPS 1 in work.
This is an instantaneous launch window, so if it doesn't hit the time that I have
and EHA buses enabled
over there, then it will have to...
Step 372, arm tell for rapid retract.
And in work.
Hold on. Okay, I'm just listening to see if we're missing anything. But yeah, basically, if it doesn't hit that T-minus time, that is very confusing. Let me try to put this somewhere that you might actually be able to see. How about there? Sure. If it doesn't hit it right on the nose, then it will scrub and have to go to another day. It's an instantaneous launch window. That's because it has to line up with the exact orbit of the International Space Station, the exact inclination. Yeah, people in my Discord are asking, why does it look so packed and cluttered? That's just kind of the way this launch pad is. It is a very compact little pad. This isn't a very big rocket. Although it's putting out as much power as the RD-180 from an Atlas V, so it is a very, very powerful rocket. But in total size, it's pretty small, and it's a nice compact pad. And actually, wait, directly in front of us, this is confusing because in front of us, you guys see this black thing right here. This is Rocket Lab's new launch pad because they're going to be launching the Electron. That's really confusing. So there's some perspective stuff in play here. That looks like it's so close though. That's crazy. I didn't know that Rocket Lab's launch pad is going to be bumping in and making an appearance here in today's stream. But yeah, so
this morning we are joined by Christina Halona, Program Manager for Antares Systems, Engineering, Integration, and Test, here with us from Northrop Grumman today. Thanks for joining us.
Thank you for having me. I'm excited to be here, and good morning to everyone who's joined us this morning.
So can you tell us a little bit more about your role?
Sure. As the Antares Systems Engineering and Integration Test Engineer, Program Manager, my role is to provide systems engineering leadership to efficiently and reliably execute Antares cargo resupply mission to the International Space Station. My team and I work to increase the focus on clear requirements development, interface design, testability, and verification. The system engineering is an important role to Antares as we actually get to, interface with all the different engineering disciplines through across the program. And we do this to ensure that we are always in compliance with our customers' requirements and their needs throughout the program.
It's so interesting how tightly
That's
compact.
great. So there are some differences with this launch that we saw this before on Northrop Grumman 11, but we're seeing it again on Northrop Grumman 12, the late load option for cargo on Cygnus. Can you tell us a little bit more about that?
Sure. One of the unique features of the Antares 230 Plus vehicle is that we have built new specialized ground support equipment that allows us to take the vehicle from vertical to horizontal. This allows us to kind of drive what we call a mobile clean room right up to the pad, as you see that there in the graphic. And this allows us to remove the pop-top fairing. We can't see it there in the picture, but there's actually a pop-top on top of the fairing that comes off. And we're able to load time-sensitive research experiments and other perishable items that NASA needs to provide 24 hours prior to launch. I'd also like to note a key flexibility feature added to the CRS-2, which is the ability for NASA to significantly alter the final cargo load by up to 20% as late as the 24 hours before liftoff. And you can't see it here too, but there's a bladder that inflates between that little opening there and the fairing, and that inflates to close the gap between the clean room and wall so that everything that goes in and out is protected.
It's very interesting, and I understand this is not the only difference for this flight. This is the first flight of the Antares 230 Plus rocket. So what are some of the differences between 230, which we've seen fly before, and 230 Plus?
Sure. So the NG-12 is the first flight of the Antares 230 Plus configuration. And the difference from Antares 230 are the upgrades to the Stage 1 core. It's also lighter composite structures and an optimized second stage mortar. The upgraded Stage 1 core allows Antares engines to perform at full thrust throughout most of the first stage profile. With these upgrades, we're able to offer NASA more cargo capability for their CRS-2 missions by increasing the performance of Antares. We're also providing more flexibility for the final cargo load as well. And this figure everyone can see is the differences, and you can see in comparison how much we've kind of taken off. And there's definitely lots of mass savings for us for 230 Plus.
Great, more efficient and able to deliver more cargo, so that's what everyone wants.
Oh, yes, and we'll be doing that for 230 Plus going forward.
Cool.
Thank you so much, Christina. We are now just over 17 minutes from launch of Cygnus. We'll be looking for that at 8:59 a.m. Central and 47 seconds, 9:59 a.m. Eastern and 47 seconds. But the teams have been progressing smoothly throughout the morning through some pre-launch milestones. That began about 4 hours ago with poll for readiness for the launch vehicle to be powered on. And then an hour and 20 minutes before launch, fueling began of the first stage. That's liquid oxygen and R21 kerosene.
Roger that. System will check 379 complete.
I do want to point out the good old the rocket reminder is not smoking right now. That's actually just condensation, because the vehicle runs on on basically kerosene or jet fuel. RP1 is called, rocket propellant 1, and liquid oxygen. And of course, liquid oxygen, in order to take oxygen and take it from a gaseous state and cool it down to a liquid state, it has to be unbelievably cold, like really, really, really cold, and so cold that not only like things that come in contact with the skin, air that comes in contact with the skin will condense and create these little clouds of condensation. Just like when sometimes if you open your freezer or something, you might see little bits, or dry ice or something, you'll see bits of condensation pouring off of it. But also when it purges, when it goes from liquid, and as it warms up, it'll actually expand out and turn back into a gas. And in order to not overpressurize the tanks, it actually just has to vent out. So that's what you can see that vent line up at the top. And that's to make sure that the rocket is not overpressurizing as some of that liquid oxygen boils off and turns into a gas. And of course, it's still really cold. So again, it creates this nice little cloud of condensation. And now you know. All right, let's listen in here and see if we're missing anything else. Oh, Sweet.
And
So
Core 1 LC, countdown 1.
I forget. I think this is only a 2-stage rocket. For some reason, I was thinking it was 3. I thought
this is Core 1 on
All Cygnus
Can someone
vehicles are
remind me?
named after people who have made
Discord,
significant
help.
contributions to spaceflight
Ooh, Alan
but
Bean,
have
yeah.
passed away. And this vehicle is named after the late Apollo and Skylab astronaut who died on May 26, 2018 at the age of 86. That's Alan Bean. It's very appropriate that Cygnus is named after Bean on this mission. It launches 50 years to the month after Alan Bean, Pete Conrad, and Dick Gordon flew to the moon on the Apollo 12 mission, in which Bean became the 4th human to walk on the lunar surface. He was the lunar module pilot aboard Intrepid with Mission Commander Conrad when they landed on the moon at the Ocean of Storms on November 19, 1969. 4 years later, he commanded the second crewed Skylab mission, Skylab 3, which launched on July 28, 1973. Bean, Owen Garriott, and Jack Lousma spent 59 days in space aboard America's first space station. That's Alan Bean, and we will see the Cygnus named after him flying very shortly today.
Roger that, prompt 2. Check step
Alan
3.
Bean also became a really good artist and continued painting for the rest of his life. I almost got the chance to meet him last summer at Space Fest in Arizona, and unfortunately he had just passed. And he even had his art show there too. So it was cool to see his artwork. He's a phenomenal artist, and yeah, he was an awesome astronaut. And from my understanding, from everyone that's ever talked to him, just one of the nicest humans ever. So it's really cool that Northrop Grumman and previous orbital ATK would always do these, and also this also is done by ULA, where they will dedicate their launch to somebody, which I think is pretty cool. So
CMD LC, countdown 1.
so I'm gonna keep listening in here. One of the things
And
to mention.
CMD LC, countdown 1.
CMD, countdown 1, go ahead.
Yeah, CMD, looking for status on your internal power.
Yes, Cygnus is on internal power and nominal.
Roger that. We'll check 384 complete.
Cool. Yeah, so, here you can see a really good view of how close Rocket Lab's pad is. It's not as close as it looks in that one shot. That one shot makes it look like it's literally on the same pad.
TMLC on countdown
Wow.
1. At this time, I'm going to poll to proceed with final countdown. GSO,
GSO, go.
RSO, RSO's go. TD,
TD is go.
prop lead,
Prop lead is go.
stage 1,
Stage 1 is go.
MES1,
MES1 is go.
GC,
GCE go.
ACE,
ACE is go.
Mars,
Mars is go.
CMD,
CMD is go.
LD,
LD is go.
NG.
In honor of Alan Bean, who shared the gift of exploration in both life and art and inspired future generations to travel back to the moon and beyond, Northrop Grumman is go.
Sweet.
Copy. And we are going to proceed with final countdown. Check step 386.
Good. That's what I like to hear. We are go. And by the way, Mars is go. It has nothing to do with the planet Mars. The launch complex out here at Wallops in Virginia is called Mars. So this is Mars Pad 0, I think. So yeah, it's just funny that they just call it Mars, so that they're kind of saying the complex is go, not the planet. The planet's ready. But here you can see how close Rocket Lab's launch pad, that little tiny black tower. It also gives you a sense of scale to how much smaller the Electron is compared to even a relatively small rocket like Northrop's rocket here. But I'm really excited to see the Electron launch from there.
And Ops 2, LC, countdown 1, step 387. Go to start engine evacuation.
Engine evacuation started.
I don't actually
You
know
just
what
heard the
means.
poll to proceed with the final countdown, and we're also watching some ducting happening off the rocket. We can't really see the Antares logo so well anymore. So, Christina, can you tell us a little bit about what's happening there?
Sure, you can see the top half of the first stage of the vehicle is really cold with that cryogenic liquid oxygen. The Antares logo is almost completely obscured by ice, as you can see there. The evaporative process is happening, so the liquid oxygen is blowing off of its relief valves. That is super cool.
Sweet. Yep, that's what we mentioned, the whole condensation thing too. So, oh man. Oh, I'll put my timer up. I don't like that they keep taking away the countdown timer. Give us that countdown timer, people. I want to see that time. But yeah, again, really good shot here of how close the Electron pad is. Look at that, and it's almost done. They're hoping to fly, I think, really soon.
Just under 10 minutes until launch of Antares. Things continuing to proceed smoothly throughout the countdown this morning.
Oh. They put up the time for like 2 seconds. I'm like,
once
right,
we get to the launch, the first thing that will occur is the stage 1 ignition. You'll see liftoff just a few short seconds afterward, and those main 2 engines will burn for about 3 minutes and 18 seconds before cutting off, and stage 1 will separate from the rest of Antares. Cygnus will coast for a bit until fairing separation, when the external cover that protects the spacecraft during launch will separate. The interstage adapter that connects the first and second stages will separate at 3 minutes and 58 seconds into flight before stage 2 ignition, a solid rocket fuel that will burn for 2 minutes and 43 seconds. Once the second stage burns out, we'll be listening for the call of orbit insertion for the rocket at 6 minutes and 49 seconds after launch. The vehicle will coast for 2 minutes before Cygnus separation, 8 minutes and 49 seconds after liftoff, with solar array deploy occurring about 2 hours and 53 minutes after launch. The deployment of those 2 Ultraflex solar arrays currently tucked away on Cygnus takes about 30 minutes, and then the vehicle will begin gathering power for the next couple of days during its journey to the space station.
I really like those solar panels, how they...
We haven't showed the wall.
Oh, what was that? So just for those of you asking, I have my own countdown clock that's synced to like the internet, that one, and they keep popping up there sometimes. So I don't know if I should just keep mine. I need to update mine, by the way. That's just like that was a temporary thing. I sometimes have another one that looks better when I'm streaming from a laptop. Anyway, so this, just to confirm, this is only a 2-stage rocket, and the Antares can fly with 3 stages. I believe. Am I totally making that up? But today it's only flying with 2, and I think with Cygnus it only flies with 2. I don't know why I was thinking it was 3 stages. I don't know. Oh, I know what I'm thinking of. I'm thinking of what's that next rocket they're working on too? That's going to be backwards basically. It'll be a solid first stage, solid second stage, and a liquid third stage. That's what I was thinking of, and that's the. Someone help me out. It's too early. My brain I still have jet lag? I thought that would go away after like a few days. Ooh, there's some atmospheric distortion. Someone help me. Sorry, the sound of fueling apparently was getting very loud. Hopefully I corrected that there. Yeah, we fixed it now. Thanks, best buddy. Therion asked, where exactly is that Rocket Lab pad? I'll try and show you guys here. There, right here, to the right of the water tower right now. This is a perfect shot. You can't see my mouse, actually. Oh, maybe you can. Maybe? Not really? No, you can't. Nope. Because OBS has it blocked off. But yeah, it's that tiny little stick right now. This is actually a perfect shot for that. I wish they didn't have that sound of fuel up. Oh, Omega, that's what I'm thinking of. Omega rocket is the other one that Northrop's working on. And that's definitely a 3-stage rocket, and it's 2 solids, and then the upper stage is a liquid-fueled rocket, which is really interesting. Yeah. Yeah, I did call the orbital. This is a relatively small rocket. Again, the whole thing is shorter than the Falcon 9's first stage, so it's by comparison a small rocket. But that kind of also tells you how big of a rocket you need. Oh, there we go. Now we can listen.
5 minutes and 45 seconds until the launch, and the next milestone for Antares will be for the vehicle to begin turning on to internal power at 5 minutes.
So right now, between us, the little black streak you see in front of the rocket, that is actually the Electron's launch pad. And just perspective right now, it makes it look like it's almost part of the rocket or part of the... It actually looks like it's part of their transport erector or their actual, support structure. But it's really a good 100, 200, 300 meters away. I don't actually have a sense of distance.
Will be not required for today's operation. And Ops 2, you go to initiate engine priming at T-minus 5 minutes.
Okay.
Engine priming started.
Ops 1, you go for step 398, transfer avionics to internal power.
All internal power on selected. Standing by for command completion.
Sweet.
All external power off.
Vehicle's entirely on internal power now.
And now Elec 1 confirms internal power is nominal. Ops 1, step 400, open FTS umbi loop and verify green indication.
FTS umbi loop open and green.
Does look like an obelisk.
LC Elec 2, FTLU, and FTS receiver indications are nominal.
Ops 1, step 402, send all arm command.
Oh, come Quat Lord. Vega Rocket's another one that's 3 stages. Dylan, you got a full flow shirt.
LC Elec 1 confirms SNAs and ODMs all armed.
Thank you.
TD, report range status.
LCTD, range is green.
Copy, range green.
LC MES 1, step 405, priming verified.
Copy, priming verified, check 405 complete.
Three minutes and 30 seconds until launch.
Why don't they have their
everything continuing to proceed nominally for Antares.
Phase 3 dynamic limits will be active at T-minus 3 minutes.
Looks like my clock is about 30 seconds ahead of the live stream. Probably the delay in their live stream getting to my eyeballs and my stream, and then, yeah, that makes about sense. 20 to 30 second delay.
FC command into flight mode.
So hopefully they put up their countdown clock. Come on, NASA. You can do it.
Auto sequence start. ODM bus voltages and currents nominal.
What a beautiful morning.
Elec 1. GNC 1, step 411, verify ready for nav mode.
LC GNC 1, ready for nav.
And Ops 2, step 412, switch to nav.
LC Ops 2, switch to navigate.
LC GNC 1, orb nav telemetry verified.
Copy that, GNC 1, check step 413 complete.
Thank you to all of you that are commenting that you got your merch. We got slammed on merchandise. Like my store. Oh, there's the real countdown. Let's watch that one. Turning mine off. There we go. I got slammed.
T-minus 2 minutes.
After the Elon interview. And my shop manager, the guy that runs the store, had a baby. Like at the exact same time.
Mark.
So we got destroyed. So thank you for all of you that have ordered like full flow shirts and aerospike shirts and stuff. I'm glad you guys really like it. That means a lot. That's awesome. Thanks, Dylan, and thanks, best buddy Monka. Jeffrey Tripp, I will definitely get
1 minute and 45 seconds until launch. Everything proceeding smoothly for Antares and Cygnus.
That might be a decent video idea.
Still looking at an on-time launch at the opening of a 5-minute window.
Oh, we have a
launch
5-minute window.
8:59 a.m. Central, 9:59 a.m. Eastern.
I'm sorry, guys. I thought it was an instantaneous launch window. There's a 5-minute window. That's great. Allows for a little bit of flexibility. But normally if there's a problem with the rocket, it's rare that it'll be fixed in 5 minutes, but it still helps.
T-minus 1 minute.
Yes, let's do this.
Mark.
There's not a usual for launch windows. People asking. It depends on the vehicle, depends on the conditions. Falcon 9 is instantaneous for these commercial resupply
Range
missions.
Is green, weather is good. 40 seconds until launch.
Cameron Lars in our Discord wants to know, does it have RCS? Yes, that's how it also gets into finalizes its orbit and does all that stuff too. And then it is berthed to the International Space Station and not actually docked, so that the International Space Station will grapple onto it and pull it in towards itself.
20 seconds until liftoff.
Let's do this, baby.
T-minus 10.
Here we go.
5, 4, 3, 2, 1.
Oh, there it goes. Yeah.
NG-12 mission, Wallops flight facility.
Whoa.
Engines at 100%. Attitude nominal. Power nominal.
That was an awesome shot with the engines. I feel like you could see the explosive bolts. I think that's what that was, and a green flash. It looks like they also use T-tab or some kind of pyrophoric ignition source. Look at that! It flew off the pad too.
Engine performance nominal. Estimated alpha, 1 degree. BNO3 is open.
I should confirm it's actually pyrophoric, just so you know. Hypergolic and pyrophoric are different. Pyrophoric reacts to oxygen. Hypergolic react to each other.
Power is nominal.
I like the cheering. That's cool.
Estimated alpha, 1 degree. Engines remain at 100% and steady. Power's nominal. Load relief, phasing out. The NG3 is open. Roughly 100 seconds to MECO.
MECO's main engine cutoff, of course. That's the first stage.
Everything proceeding smoothly, about 100 seconds till main engine cutoff.
Just passing 100,000 feet. 100 feet per second squared. High altitude pitch up at 5 degrees.
Little photobomb by some birds.
Enabling velocity steering. Engines remain stable.
Yeah, baby.
1 minute to MECO.
And some companies call them BECO, booster engine cutoff.
Engines remain at 100%.
ULA tends to call it that. And they call their upper stage MECO.
Attitude is nominal. BNO4 and BNO5 activated. Power nominal. Just passing 200,000 feet. Slow throttle down to 80% initiated.
Main engine cutoff coming up in about 15 seconds.
Engines 55%. Engines remain nominal. Main engine cutoff, nominal.
Yeah, baby.
PSS disabled. Stage 1 separation. ACS enabled.
Attitude control thrusters.
Attitude nominal.
And now it's so far downrange.
Graphic Cygnus is separated from the stage 1, and in the next few seconds we'll be looking for the fairing separation. That's the shroud that covers and protects Cygnus during its launch.
Stage 1 ignition time projected at T plus 245. Fairing separation. Interstage separation. Stage 2 ignition.
Stage 2 is that solid rocket fuel that will burn for about 2 minutes and 43 seconds.
That's fast. That is a quick way to get into orbit.
Everything proceeding smoothly for Cygnus.
So the big thing is here, this apogee.
Avionics power is nominal.
its highest point's not going to change that much, but notice because it's going horizontal, the lowest point of its orbit is actually
reaching
raising.
135 kilometers.
So right now, if it were to cut off, it'd fall to minus 4,800 kilometers below the ground. That's how...
Stage 2 TVC is nominal.
And as they speed up, it actually raises from the center of the Earth, basically, until it matches...
Power subsystems remain nominal.
A circular orbit. So we're seeing that perigee, or the periapsis, increase in altitude, because right now it's negative, and it's going to increase.
Altitude has just reached 150 kilometers.
Stage 2 continuing to propel Cygnus now at 1,100 miles per hour.
Wait, did you say 1,100 miles per hour? Probably 11,000, yeah.
Power and TVC systems remain nominal. Attitude nominal.
Notice the altitude right now is 170 kilometers, and it's only going to go up currently at this point to 195 kilometers. This is its highest point.
We are nearing 1 minute to stage 2 burnout.
So it's mostly pointing straight sideways and working on accelerating itself to circularize the orbit. And it is cruising. I feel like this thing has a crazy high thrust to weight ratio.
Attitude nominal.
Seth in our
Altitude,
Discord.
180 kilometers.
I think this animation is actually linked to the telemetry, by the way. People are asking. I don't think it's a predetermined animation. I'm pretty sure it's linked
subsystem nominal.
To telemetry. I'm going to keep listening into all these call-outs, but they might be a little distracting talking over them. This is we have 30 seconds till... Wow. Yeah, this is a quick way to orbit. This is probably the fastest way to get to orbit. There's attitude control thruster shooting. Seth wanted to know if there's a difference between apogee and apoapsis. Apogee is specific to Earth. Apoapsis is generic to any body that is orbiting. So there's apohelion, all these different names depending on what body it's orbiting. So, but apogee is the... Oh, there we go. Apoapsis is the generic. So stage 2 burnout, we're going to hear hopefully a good call out.
Disabled.
Flight termination system is disabled, so it can no longer blow itself up, because if right now nothing happens, it'll burn up on reentry. So they don't need to have flight termination.
Attitude nominal.
Stage 2 burnout confirmed. Cygnus moving at over 16,833 miles per hour.
It's amazing.
Active.
The next milestone will be Cygnus separation at about 8 minutes and 49 seconds after launch.
Power is nominal. Antares will coast for roughly another minute prior to payload separation. Systems continue to perform nominal.
It's a good...
Altitude, 190 kilometers.
Good question, NeverPie. So eventually... I'm actually... Ooh, wow. One nice clean insertion. But I don't really know why they would need to turn off the... Oh, hold on. Sorry, I want to listen to this. The flight termination system, they do seem to turn off pretty late, but...
Power is nominal.
I'm not sure. Sweet. Waiting for spacecraft separation. The Cygnus capsule will detach from the spent solid rocket booster.
Spacecraft separation.
Good. That is awesome.
Team celebrating the confirmation of the spacecraft separation. Cygnus is now flying on its own.
Maneuver initiated. LC, that will end our call-outs here for the NG-12 mission for Antares.
Excellent job, Ace. Excellent job. Good launch all the way around. Let's go ahead and continue with our post-launch checklist on countdown 1. And Prop 1, step 423, can you give me status on pulse purging?
So awesome. Yay. Congrats, NASA, Northrop Grumman. Seems like a good mission so far. I'm still listening to what they're saying. I'm gonna just kind of tune them out for a little bit and see if anything else pops up. But I'm gonna keep them up on screen, and I want to answer some of your guys' questions because it's been a little while since we've been able to hang out and talk. We haven't had a launch for quite a while, so let's see. So Jeffrey Tripp, I think that's a really good video idea. Are 3 stages better than 2? And we can kind of talk about the difference. There's definitely some advantages depending on, it depends on a lot of things. There's a lot of variables, but it depends. And that'd be a good topic for a video. Kumquat Lord, not anything publicly, no. But I could do a video on SRBs. Refermed, what is the ISS? The International Space Station. That is the most complex thing humans have ever put together, arguably that and CERN, CERN's Large Hadron Collider. Those are probably the 2 most complicated and expensive, biggest endeavors that humanity's ever done. The International Space Station is one of the most expensive things ever built. It took tons of launches to get all these parts up. And don't forget, every launch, you have to accelerate something 10 times faster than a bullet and then rendezvous them in space and turn it into one coherent space station. The ISS was primarily built by the space shuttle and also by Russian progress vehicles. Yeah, pretty stinking cool, really. It's primarily a giant floating laboratory, and it's a way for humans to learn how to live, work, eat, sleep, breathe, do all these things in space, and just how to survive long term. You know, people have stayed up on the International Space Station for about a year at the longest, but most rotations are about 6 months now. A crew of 6 is up there basically at all times. If you are born, if you're under 19 years old, you have never lived in a time where there's not a human in space, like continual presence human in space, and that's thanks to the International Space Station. So there has always been a crew on board for 19 years now, which is crazy. They do overlapping, 6 people on, then they'll take 3 down, and 3 will come up and replace them, and then those other 3 will go down 3 months later, and 3 months. So yeah, it's like every crew rotation 3 months, but there's always 6 people on station at all times. So yeah, I think that's pretty crazy that it's all the things that we've learned. And one of the big things that people always ask, why use the International Space Station? If you're doing like long-term, say, growing cell cultures or studying something that you can remove the variable of gravity, because gravity, will pull down on like plant cells, pull down on our cells, it affects things. It even affects how heat is, dissipated from things. I'm actually talking about that a little bit here in an upcoming video about cooking and baking in space, because that's actually something that's really interesting. How do you bake? Normally when you have an oven, when you bake, all the heat rises, so you can put the cookies or something on a sheet in the oven, and all the heat will rise and heat it up. Well, in space, the heat doesn't rise because it just doesn't. It radiates out in this like weird gradient. So how do you cook? We've never actually cooked anything on the International Space Station. Actually, on this flight was the first time we're actually putting an oven up on the International Space Station. So I'm going to talk to you guys about that here in a video in the next couple of weeks. It's really interesting how you actually, and that's definitely like a long-term thing. Like if we're going to say Mars, or even if we're out going around the moon and out there for months and months, you definitely want to be able to, I think, have more variety in your food. So, things like baking cookies and stuff like that is definitely probably a warm welcome as opposed to just rehydrating food and warming stuff up. So, yeah, so that's what the International Space Station is. We learn a lot up there. We learn a lot about our own human bodies, even down for Earth, like how, again, being able to remove the variable of gravity is helps us understand a lot of, it's basically looking at sometimes the same problem, like say cancerous cells or something like that. You can look at the same problem in a new setting and learn a lot more about it. And it's actually it's a really incredible program that I wish people had more appreciation of. Let's see here. Okay. Mr. Scholl started without confirmed pointy end up. Lucky, you're right. And I didn't even do it. Wow. I didn't do my job at all. I did not even do my job. I didn't check if the pointy end was up, flaming end was down. Don't fire me, guys. I'm so sorry. John Holleran, how many trees does it take growing from maturity to process the CO2 from each rocket? No, John, you're exact. That's a video I've been working on actually for a couple months. Ooh, here we can see the replay. Yes, you can see there was like explosive bolts on the piping that gave out. That was awesome. That's so cool. Sorry, I'm gonna make it big. I want to replay that because that's really cool to me. Watch this. Watch the pipes. Pfft. That's so cool. Okay, sorry, I got excited by that. Fast forward. John, you're exactly right. Actually, that's a video I've actually been working on for a long time. I got the invitation to do a video for Team Trees right like 3 days before I left for Europe on my first actual vacation kind of the year. And I still did work, of course. And I got to meet up with 45 people came out and hung out with me in Vienna, which was shocking. Super cool meeting all you guys in Europe. I loved it. It was so fun. We hung out for like 5 hours, and it was super, super fun. Say hi if you happen to say hi in the chat right now if you happen to meet me in Vienna. That was really, really fun. That's a video I'm working on, and I want to have it done by the end of the year, even though I think they're gonna hit the 20 million trees really soon. Really soon. It is flying off the shelf. So I'm really excited about that video, though, in general, just about the pollution of rockets and the not only the pollution of like what we're seeing here, the air pollution and potentially, greenhouse gases, but also the pollution of when they fall in the ocean. So ocean pollution, and as well as I'm even going to take into account space debris and space pollution. So it's going to be a pretty in-depth, comprehensive video. Hopefully probably around 30 minutes, knowing me. So I hope you guys like that one. I've always wondered that, like, what's the pollution of rockets, especially with like Elon Musk being so obsessed with, green initiatives like, Tesla. It seems a little counterintuitive for him to be using rockets, right? Chemical propulsion. But we'll talk about that, and we'll show you just how insignificant amount of pollution, like a rocket is like literally 0.000007, I think, % of the output. One rocket launch is 0.00007 of daily airplane flights. So yeah, we have a lot bigger fish to fry in that scale. Yes, rockets pollute, but like compared to even the airline industry, which is only like 2 or 4%. I don't remember. These numbers are coming off the top of my head. I have these numbers that we're working on. The airline industry is still only 2 or 4% or something, like a very small amount of global pollution. So then you look into things like the shipping industry and natural occurrences like forest fires and stuff. And rocket launches are not even a speck, not even a blip on the radar. So it'll be something interesting to talk about. I bet you global leaf blower usage. That'll be really interesting for me to find something that pollutes more, that seems really insignificant. I will guarantee global leaf blower usage is like several orders of magnitude pollutes more than all rocket launches combined per year. Yeah. So that'll be my Team Tree video. So stay tuned for that. That'll be hopefully I'm going to have that one out here in November. Cole Logan, your 3-year-old twins love the launch. That's awesome. Say hi to your twins, and thanks for saying hi here. Timothy, are you going to cover the Starliner test on Monday? I think I'm going to. Starliner is going to do a pad abort test out, I believe, in Nevada, which is cool of their Starliner. So testing the abort system to make sure the crew is safe. They use a liquid-fueled abort system and some modified Bantam RS-88s, 4 of them to do a liquid-fueled abort. Similar to the Dragon capsule has the Super Dracos, Starliner also has liquid-fueled abort. I have a video all about abort systems and all that stuff. If you want to learn more about why Boeing and SpaceX are using liquid fuel pusher systems, and also why Blue Origin is using a pusher solid motor in their New Shepard. I have a video all about the pros and cons of liquid fuel versus solids, and pusher versus the tractor systems like what used to be on the Apollo capsules in previous generation. And even the Orion capsule has a tractor system, a abort system that's in front of the module. So definitely watch that if you're interested in that leading up to the abort test on Monday. I'm looking forward to that because that's a good step in the direction of we're actually going to see this thing fly with humans very soon. Please, I am so ready to see humans flying from on new vehicles and from U.S. soil. Will be really fun for the first time since 2011. So I'm really excited for that, and you guys should be too. And it's obviously nothing against Russia and the unbelievably reliable Soyuz rocket and Soyuz spacecraft, but having some redundancy and multiple ways to get humans to and from the International Space Station is always a very, very good thing. So I'm really excited. Jason, someone asked why AP continued to rise after engine cutoff, because solid engines don't just switch off. Correct him. That's probably, I'm guessing you're talking about apoapsis or apogee, why the apogee continued to rise after engine cutoff, and not so the altitude would rise in general, but even the apogee would probably rise slightly because yes, even as all engines are solid. Solid engines, liquid engines, they always have a little bit of residual thrust after shutdown. There's just going to be still hot gases expanding, and that might be for several seconds. So it will still produce some residual thrust. And they actually, they calculate that in, and a miscalculation of that residual thrust is what led to the third failure of SpaceX's Falcon 1 rocket. It made it so that they had made some tweaks to the engine. They didn't realize that it was still going to have residual thrust as long as it did. They did stage separation, and because of the residual thrust, the first stage bonked into the second stage, and it ended up causing a failure of the launch. So, there's always residual thrust, and that would probably explain why the apogee would raise even after engine shut off. Good question. And also even timing between engine shut off and the animations and stuff and telemetry might be, there could be a second or two delay there as well. Let's see here. Eric Huff, great stream. Where exactly is this launch site? So that's a good question. Let's pull it up here. This is Mars Pad 01, or Mars LP Launch Area 1, LA 0. I keep saying 1, reading it 0. Thanks, Europe. You really messed me up because your ground floors are 0 and the second floor is 1. So clearly that's what happened here. Launchpad 0. My God, maybe I can read someday. But yeah, this is in. Let's pull it up on a map. That will help. Coordinates. Why isn't this? Come on, give me the good stuff. Put this up in Google Maps for me. Please, I don't want this. I don't want this. Oh, okay, this is embarrassing. This is called Can Tim copy and paste anything? And the answer, clearly, no. God, what? Okay, whatever. We'll just go maps.google.com and Mars LP0. I don't know if this will work. Or maybe it's LA0. I can't read anything. LA0. I can't read. I can't internet. I can't talk. I can't do anything. Well, I would love to show you on a map, but basically, let's see, Virginia. How about we look up Wallops first? Wallops, Virginia. Okay, so here's where Wallops is in. Oh, let me go full screen for you guys. Here's where Wallops is. Here's, what is this? New Jersey, Delaware right here, Maryland, DC. And even though it's really close to DC, in order to get out there, you have to drive like all the way around. I hear it's about a 4-hour drive. And right out here, at just this very little tip, is Wallops. So the launch pad's out here. Hopefully that answers your questions. Yeah, I've never actually been to Wallops, for those of you asking. And I hope to soon. That definitely sounds like a lot of fun to me. There you go. Okay. Liquid Chris, how's it going, Liquid Chris? It's been a while. Welcome back to chilly Iowa. It is cold right now. It's 35. I'm not ready for this. I am not ready for this. But thanks for saying hi. Adam, how's it going? Why not put a space elevator on the moon? Well, the moon actually is almost less necessary for a space elevator because it has such a low gravity environment. But it would be easy. I don't know. I'd have to look into that because a lot of it also depends on the rotational speed. As a space elevator, here's the thing. From the surface of the moon, you could, if you're on a high enough point on the moon, like say the tallest point on the moon, and you literally launch straight sideways, you'd be in space. And a space elevator, even if you raise it up, say 100 kilometers, and then you let go of something, it's just going to fall straight back down 100 kilometers. It needs to go all the way out to geostationary orbit. And I don't actually know if, someone tell me, where, I don't know if the moon spins fast enough to put something into geostationary orbit for itself. I don't know if you can do that because here's the thing, like same with Earth. Earth spins pretty quickly. You know, it takes 24 hours to do a single rotation. A real space elevator, I think you'd have to have something tethered in geostationary orbit or near it and take it most of the way, and then maybe give it a little bit of a throw or a huck. But yeah, so I don't think I don't know if that works. I don't know how that works actually, guys. Because it doesn't rotate. This is crazy, guys. I don't actually know how this would work, and I'm gonna try to look into it really quick. Someone just tell me what would happen, because that actually is boggling my mind right now. I am not. Full disclosure, I think this is pretty obvious. I am not an astrophysicist. I only know enough to be dangerous about a certain amount of things here and there. So, yeah. Anyone know the answer? Anybody? Yeah, it rotates once a month. Yeah, which is not going to be nearly enough. Hang on. Dang, yeah, that blows my mind. Boop, 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 boop. Research in Kerbal. Let's see. Oh yeah, sorry guys. For those of you saying yes, 35 degrees Fahrenheit, so like a degree Celsius. In other words, it sucks here right now. Although I kind of don't mind. Let's keep answering your questions, and meanwhile, we'll maybe figure out that option. Yeah, that's true. So just so you know, you can technically, well, I don't know. We'll figure it out. That's why, Adam, Kevin, a new spacesuit. Well, thanks, Kevin. I probably won't ever be putting a spacesuit back on. Honestly, I appreciate that. You can retract your funding if you don't. If you were intending for me to get a new spacesuit, I do want a new spacesuit to hang up on the wall, something that represents, and someday I will do that. But as far as me putting on a spacesuit again, that just ain't me anymore. I realized the Everyday Astronaut project should have stayed as the art project on like Instagram and as photos as the Everyday Astronaut project started. But nowadays, I just really I feel better just being myself and just wearing clothes and not trying to be the character of Everyday Astronaut. I realized that I realized this, that there is a better chance, like no one would ever click on a video of mine and say, I'm not going to listen to this guy, he's not wearing a spacesuit. But the inverse very well, and was true. I had a lot of people telling me, like, all the time, why would I watch this guy wearing pajamas and stuff? Like, it was more, like, and I'd rather risk being overly available to everybody as opposed to anything that could be remotely ostracizing or come in between me and the audience, right? Like, and just being transparent and a normal person. Like, I realize that's probably more important than what now kind of feels a little bit like a gimmick of a spacesuit. So, yeah. There we go. That's true. There's Lagrange points on the moon. Yeah. Wait, what's going on? Do we actually have... Let's see. Okay, so John, the pollution video sounds amazing. Here's extra few bucks. Well, thanks, John. I hope it ends up being really good. Trolling, thank you very much. Definitely not reading that, so thank you, Mike. Is Elon going to use tie-down straps or the system they use on a barge to hold the rocket from tipping over from Mars, like it did on Earth from high winds? That's a good question. We don't have any details really on that. I wouldn't be surprised if SpaceX or companies that are landing large landers like with Starship, if they have the ability to just articulate the legs manually or automatically, I guess, but like manually as in like not passive landing gear, because they're not passive landing gear. They can retract and detract, untracked, retract, and tracked. I don't know. But, you know, say they land on like a boulder or something. I think they'd have the ability to adjust how the angle of the whole vehicle, or have one leg stay up a little bit. What's going on here? Hold on. I am now hearing myself. That was trippy. Yeah, so that's kind of how that would work. I think, so they won't need tie-down straps. And again, remember, there's actually virtually no atmosphere on Mars. There's so little atmosphere that even, you know, 100 kilometer an hour wind would feel, it doesn't quite work like this, but it would feel about like a very, not even like a breeze here, because there's only 1% atmosphere on Mars. So the idea of it tipping, it wouldn't need anything. The only thing that you'd have to worry about is if it landed on like a dune, like a sandy dune, that the ground underneath it, you know, might start to shift and all that type of stuff. So hopefully they land on somewhere nice and flat. And even if there's like a boulder, maybe they have a way to articulate the legs to make up for it. Let's see. Let's see here. Okay. So yeah, that would be my guess. Randy Wiedenfield. There's a recent study that came out that said a space elevator from the moon through the Lagrange point is feasible with one launch of the upcoming Super Heavy rocket. Really? Well, that would make sense to be able to put it up to a Lagrange point. That would actually totally make sense. That would be pretty cool, actually. Okay, well, maybe that's something I need to look into. Space elevators on the moon. Why not? Lagrange points, by the way, for those of you who don't know, basically if you have two bodies, there's actually ends up being like 4 or 5 Lagrange points. These are points where the two bodies are basically pulling on the vehicle or on the subject or the object the same amount, so it doesn't end up, you know, going anywhere. They're not always super stable, so you have to kind of like perfect, you know, because you're balancing. Think about it like balancing on the tip of like a pen, and like you just have to kind of constantly make sure you're perfectly balanced on there. So that'd be a great place to easily launch from. Just climb a space elevator. Interesting. Okay, now I know. Thank you for teaching me. And that's the whole, guys. A friendly reminder. Again, I'm not a subject matter expert on anything. I am in a perpetual state of learning, and I encourage all of you to be in that same state as well. You know, I don't sit here and pretend to know even remotely close to everything at all. I know just a handful enough to be dangerous in subjects. But I'm still learning about everything. That's why some videos take me so long. Like the Aerospike video took me 3 months. The Full Flow video took me about 3 months to research and edit and script, because I have to learn that stuff. I don't know any of this stuff. So instead of maybe if you're someone out there that's being like, oh, you don't know anything, thanks. But also maybe it should be an encouragement to you if you feel like this is all overwhelming stuff that you can start learning at any time about anything, really. You know, rocket science is like still kind of one of the holy grails of learning about physics and learning about the world we live in. Appreciating and knowing all the mechanics behind rocket science is very difficult, and it's something that people go to school for a very long time for a very good reason. A very good reason. That's why I don't pretend to know even remotely close to everything, but my learning for the matter and for the subject, because it's kind of so innocent, I hope that it makes it so it's easy to digest for you guys, and so that all of you can also join me in the learning process. That's kind of the whole point of my whole channel is that stance that like I don't know anywhere close to everything at all, and that's great. Because of that, I can learn along with you guys, and I can learn new things, and I can apply those to new videos, and still be excited about the learning process along with you guys. So just a friendly reminder that I never claim to be an expert in anything, and anyone that does claim to be an expert better be a PhD doctorate that has studied the thing for 30 years, because there's very few actual experts in the world on anything, and those people are incredibly talented people that work really hard. And that should be a reminder to you, if you actually want to get into the aerospace industry, guess what, guys? You better work your butt off in school. You better be going to school for aerospace engineering or, you know, mechanical engineering or something. If you actually want to work on rockets, you're not going to get there by playing Kerbal Space Program, unfortunately. I know it sounds fun, but you need to pursue academia, and that's still the only way you can actually learn and be qualified for a job like that, especially in the world of like engineering. Being an armchair engineer like me, easy. Being an actual engineer, very hard and a lot of work and very important. There's a lot of lessons to be learned. Okay, so let's see. Very interesting, Randy. I will look up on that. Earth is in lunar geostationary orbit, isn't it? Kind of, but not really. It's just because it's tidally locked. I don't believe it's a geostationary orbit because it's not orbiting the moon. Yeah. Let's see here. Wacom, Earth is lunar stationary. Again, kind of, but not really. But I mean, it is stationary in the sky. It's a fixed point in the sky because of being tidally locked. But yeah. Fatter, hey Tim, and thanks by the way, guys. Is Earth with Starship better for Earth than flying in a plane? That's something we're going to talk about. We're going to compare someday if point-to-point transportation with something like Starship running on methane. What's the what's the greenhouse and the CO2 output of a vehicle like that compared to jetliners? And when you talk about passenger capacity and all that stuff, what's actually worse for the environment, and is that something we need to consider ahead of time? And or should it be mandated if it's going to be doing something like that? And maybe this would be something that someone like Elon Musk would be very interested in. Would they be required to carbon capture the fuel in order to refuel the vehicle? Should that just be from the get-go, like make it so it is carbon neutral? Yeah. I think that'll be something interesting. Evan, hey Tim, the video will likely be an hour knowing you. It's true. Am I going to do a meetup in North Cal anytime soon? I don't know, Evan. I haven't had any plans. I would love to visit, San Francisco again soon. I do love it out there. Maybe I'll try and do that this winter. I still need to do a Midwest meetup. The Midwest meetup I was going to do got canceled because I was going to do it with my friends, the Cosmic Perspective friends that I have, and they're going to do a presentation. We're going to do a meetup here in Iowa. Stay tuned. I will still do a meetup relatively soon. I promise. I'm sorry. I do want to remind you though too, like when I'm at home, like that's normally my time to like work and relax and take, not be thinking about like meetups and stuff like that. Home feels different to me. So doing a meetup at home feels a little weird. So I'm also a little reluctant to do it, but I know I owe those of you that live in the Midwest with me. I do owe you guys a meetup. So don't worry, it'll happen. I promise. I did want to do it with Ryan and Mary Liz Bender. So I would like to do it with them. So I'm heeding to their timing on a Midwest meetup. Cardinal Slinky, full flow was so worth the time and investment. Yay! It's referenced constantly. That's good. Thank you, Cardinal Slinky. I'm glad that people. That's the thing. I want my videos to be references going forward. If you're someone that is trying to learn about rocket science and you're trying to learn about, say, engine cycles, boom. Hopefully people point you to the full flow stage combustion cycle video. Or if you're trying to figure out, say, bell nozzles and expansion ratios, boom, here, check out the aerospike video as good references, because those things don't change. Like the reference aspect of it don't change, which is something that I think is very worth it. So thank you, Cardinal. Renau, how's it going? So what's my next hour-long educational video? Now that we've hit, let's see. Now that we've hit those, I don't actually know. Those were two big ones that I wanted to do for a long time. I think pollution will be pretty long. I don't know if it better not be an hour because I don't have time to do that right now. Especially if I want to get it out for Team Tree. I do want to do a video on, like I said, the family of Russian engines. That might end up being a really long one. There's a lot of topics like nuclear propulsion. But most of these aren't going to be really long videos anymore. These are topics that I typically can cover. The whole thing with the full flow stage combustion cycle and the Raptor engine, in order to understand that, you had to have all of the context of cycles. And you also have to have the context of why it runs on methane. In order, those are topics that are long. And that's the reason why that video is 48 minutes long. And same with the aerospike. In order to understand how the aerospike engine works, you need to understand expansion ratios. You need to understand flow separation. You need to understand all of that stuff. And so I had to lay those out. That's part of it, So other topics don't always have that, like nuclear propulsion won't necessarily have a big amount of things that you need to know ahead of time. So I don't know if it'll be an hour long, things like that, but stand by. I'll let you know. Matthew Duggar, hey Tim, good morning. I see Flamey End was up. The Flamey End was not up. No. The pointy end was up. The flamey end was down, fortunately, for this vehicle, which is great because that's the way it intended to go. Thanks, Matthew. How's it going? Randy Wiedenfield. The study said that if the space elevator was extended towards Earth, it should end about Earth geostationary orbit, 230,000 miles from the surface of the moon. That doesn't... Wow. That's really interesting to me, actually. But that kind of makes sense. Yeah, so maybe it just doesn't make any sense. Flo, what about the pollution of rockets during their production? Wants to know. Flo in our Discord channel. I don't know if we're going to get into the pollution of rockets during their production. Now we're just getting like... It does need to be accounted for, and we will just mention that it needs to be accounted for, but I don't think the production of rockets is going to be any different than, say, an aircraft, an aircraft, or similar to an aircraft. I don't know. That's a really hard one. Wow, that's crazy. OP actually has a good question. Is there food for the astronauts if, say, a rocket like this that's supplying food to the International Space Station? Is there food if that rocket were to explode? Yes, there's normally about 3 missions worth of stockpile. Because actually we had it where I believe it was CRS-7 and a Cygnus capsule. Or no, it was CRS-7 and the Cygnus capsule worked that time. Because there was a failure before that. But I believe it was a Progress resupply vessel. Malfunctioned on the way, so they actually had 2 failures back to back that were supposed to supply the International Space Station. So I don't know if it was CRS-8 or another, maybe it was a Cygnus capsule. If that one failed, they would have actually had to evacuate the International Space Station, or could have led to a problem with that. So good question. All right, we're seeing lots of calculations on the lunar geostationary orbit. Sorry, I don't like necessarily just talking about things that I haven't researched because I might just be totally wrong about things and then showing how much I don't know. I'd rather talk about things that I do know, that I can actually answer questions that are just sitting here being like, well, maybe, because someone out there is probably just like, oh God, no. Let's see. Michael Burke, space elevators on the moon and even Mars are technologically possible now, and you only need electricity and no propellants. Interesting. Again, maybe I'll look at that someday, or just space elevators in general. Shahu, what about studying programming to work with rockets? Of course. I mean, you got to program rockets. That's a very, very, very important part of spaceflight, especially now that they're getting more and more advanced, and rockets are becoming not something that an astronaut has to sit there and control, but a fully autonomous vehicle. And I mean, they have been for the most part for a long time, but Flo in our Discord did find out that the Rocket Lab pad is only 80 or 90 meters away from the other pad, which is crazy, from the orbital pad. I didn't realize they were that close. That's basically on the same launch pad. I feel like that's kind of shocking. I bet they share that water tower then or something. Okay. Marcus Langendorf. I learned that Earth orbits the moon just as much as moon is orbiting the Earth. They both orbit around a point that's outside of Earth's surface. This is true. I mean, well, yes. I mean, there's the interaction between any 2 planetary bodies, and that's something that's interesting about Pluto and whatever the body that it's next to, is that technically the point of orbit between the two is, and by the way, no, I actually doubt that the moon pulls on the Earth enough to be, I don't know what I'm talking about. No, I'm not an astrophysicist. I don't want to talk more about this because I'm going to say something totally wrong. Charon. The largest of Pluto's moons is Charon. But basically, yes, the 2 are kind of like orbiting a point in between the 2. I don't think the Earth's orbit is outside of its surface because of the moon. I don't know. Maybe I'm wrong. No, I don't know. Yeah, the Earth-Moon barycenter, according to Lewis, is inside of the Earth. It would have to be inside the Earth. I'm 99.9% correct. Okay, anyway, that's why are we talking about orbital mechanics, the thing that I know the least about. Let's talk about rockets and spaceflight. Mouse Mac, hey Tim, are you considering taking any official courses in space stuff to become an expert, or would you go to space if you could? Come to the UK. I would love to come to the UK, and I will definitely come to the UK probably in the next year. I actually might do a speaking tour in the US and in Europe, and it'd probably be about 5 European cities and probably about 10 US cities. It'd probably be about a month-long thing, and just kind of do like some kind of live show and meetups and stuff like that. I think that'd be a lot of fun. I just think it'd be a fun way to interact with my audience and bring community together. I'm all about having people find other like-minded people. That was one of my favorite things about meetups in general is, it brings all these people together that are like, wait, you live here too? Cool. And you make new friends. And to me, that's really important because it's hard when all this stuff is on the internet, you just don't know who might live right next door to you. That's also a huge space, fan of space and space flight. So, I will definitely be coming to the UK. I don't intend to do, for me, I don't need to, it's more important for me to have a really, a top-down look on like kind of everything, and not necessarily, I don't need to be an expert in anything. I'm not working on vehicles. I'm not engineering anything. I'm not doing that. It's more important for me to have a general sense of kind of everything, as opposed to a niche or a niche, chasing down a very honed subject matter. I think that could make me actually have more tunnel vision and actually make me a worse communicator to the general public if I went down that route. And to me, it's actually more important to continually hone in on kind of this smorgasbord and capture things in my own time. I don't know if that makes sense, but that's kind of the way I feel. I think I kind of just need to keep doing what I'm doing, and it seems to be resonating with people. And I think a lot of that might be because of my informal education. The fact that I'm learning with you guys. I think that's actually kind of an important step too. So, V Stray Light, have you heard of anyone using a Starship with an arm to collect defunct satellites to deorbit them? Well, to answer that, I mean, no one's going to be talking about using Starship until SpaceX has it ready to be used. But I believe that would actually be a very strong consideration with that huge payload fairing or huge payload bay that opens up. Yes, they could absolutely potentially bring in defunct satellites. The only problem is they have to be like bolted down and stuff. You can't just stick them inside a payload. You could deorbit them though. It could be something where they could literally just like push stuff and begin to deorbit things and let them burn up on reentry. You don't necessarily have to bring them back to the ground, but just even going up to defunct satellites that might cause problems and just giving them it doesn't take much of a nudge sometimes to actually deorbit debris, even to get it into a lower altitude so that the atmospheric drag can more quickly deorbit it. I'm sure there's things like that that'll happen up more and more. So, Shahu, what about studying programming to work with rockets? Yes, absolutely. So, sorry, I don't know if maybe you didn't hear me say that before, but 1,000,000%. We definitely need programmers that program rockets. Like, that's a huge part of spaceflight. Rough demand, bring back the Hubble to put it in a museum. Yes, I am 1,000% on board with that. Once Hubble's operational time is over and it has gone out of service, it's only about 500 kilometers in altitude or 300 miles in altitude. It's not very high up. It would actually deorbit relatively quick. I don't have a decent time frame, but it's not like it'd be up there for 100 years. It'd only be up there less than a decade. I would venture to guess only a couple years because it's relatively low altitude. And I would absolutely love if we could recover that and bring it down and put it in a museum, because it's definitely been one of the most important assets of spaceflight and science. Let's see. Good questions. Matthew, you meant down. You're still waking up. Don't worry, Matthew. I am with you. I am also still waking up as we speak. All right, guys. Does the ISS have an escape module for emergency? They do always have an extra. Basically, there's always a way for the crew to get down, no matter what, and a redundant version of a crew to get down. Chris Dawson, can you see SpaceX selling their Starships to other companies to launch and make use of? I don't think that makes too much sense in their business model. I think they're probably better off just to keep it all in-house, all the launching. Maybe, but who knows? Maybe it'll turn into a thing similar to airliners, where it makes more sense to actually just sell them off to providers someday. Sell them off to people and be like, here you go. Just become worry only about the manufacturing. But I think SpaceX, Elon really likes to keep things in-house, top down. I could see him wanting to make sure they're also running the actual, selling of tickets for Earth to Earth and selling the launch services and all that stuff, and not just becoming a rocket manufacturer. Good question. Spencer J, shout out to University of Minnesota. We have one of the small sats on this launch. Proud to be on the team. That's awesome. Spencer and to the team of University of Minnesota, congrats on having a small sat on that launch. You have something in space. Something you've likely touched or engineered is actually in space right now. That's pretty crazy. Oh, I don't know if I ever shared this with you guys publicly. Hang on. Did you guys know? This blows my actual mind. Did you guys know that my stickers are in space? I did not know that was happening. Hang on, let me find that picture. Look at this. This absolutely, I had no idea. That is my sticker on the International Space Station. I can't find all four. I'll look for those pictures, but yeah, I have an astronaut, Luca. Took my stickers up to the International Space Station just for fun, and they're sitting there in the cupola now, and that blows my actual mind. I should have made a bigger deal of that when that happened, but I literally almost dropped my phone. Yeah, I think that's pretty awesome. Yeah, so congrats again, University of Minnesota. I didn't mean to take away from the fact. I just got excited because I remembered, oh yeah, I also have something in space. Having something in space is insane. Like, that's like the coolest thing ever. Yeah. So I'm going to get ready to head out of here, guys. It's Saturday morning. It's time for me to go get lunch. I did want to remind you guys, we actually have good news. I literally, while we're here this morning, we finally got the full flow stage combustion cycle shirts back in stock. You guys have been asking about this for months, or for about a month. They've been out of stock. We got that slammed that we had to do a second run just to keep up with some of the extra orders that we had, which was crazy, again, because of the whole Elon interview and stuff like that. We do finally have these back in stock. I'm going to tweet this here in a minute because we're finally getting caught up on all of our orders. So we finally did another run of these shirts. And again, if you work in the aerospace industry, unfortunately, I don't have a way to filter out students yet. But if you have if you work in the aerospace industry, you can take 25% off all my apparel in my web store. By clicking there, you'll put in your work email that will ping and confirm that you actually work in the aerospace industry. So, nice try. You can't be like space@spaceplace.com or whatever. Like, it won't work. It has to ping your actual email. So it's an approved vendors list of Boeing and ULA and SpaceX and NASA email domains. And then any of my apparel, you can take 25% off. So we do have a few things left. By the way, yeah, I have a new RUDS section of the web store, rapid unscheduled discounts. A few of these things are still available. We're sold out of almost all the prints now, though. But yeah, good sales here before the holiday season. Get them while they're in stock. I think there's only like 2 of these shirts left. Like, if we look at what's actually in stock, there's not much left for almost any of these. So, yeah, almost everything. Like, a lot of these are sold out. So if you want any of these things, get on there right now, because the rapid unscheduled stuff is almost entirely sold out. But like I said, good thing is we do have these. We also have some grid fins, but I don't know how many, so we have to check stock on that. These utility pouches are back in stock as well. And then I also there's only a few more of these limited signed editions. I actually did hand sign these. Come on, there you go. I did actually hand sign a limited number of these prints. So if you want a picture of Starhopper with my signature on it, you can get it now. That'd make a good gift if you guys want something cool for holiday season. And yeah, Aerospike shirts are in stock. Not the limited edition are sold out, but the Aerospike regular shirts are in stock, and we're getting more in stock as well too, because I think they're almost sold out. So yeah, check in soon. We're trying to really stock up before the holiday season. So remember, again, friendly reminder, everything I do, we do runs of things now. They're one-off shirts. They're actually like hand-sewn tags and stuff like that. Really high quality. Quality matters to me way more than even time frame and stuff like that. So sorry if things might sometimes take a while when we get absolutely slammed. The shop is just like a few people out in California, like hand screen printing all these things and hand sewing and I care more about the quality than quantity and all that stuff. Just like my videos. So I appreciate your patience sometimes when it gets slammed. But we are really trying to stock up big time before the holiday season, so that we can actually get stuff out to you to make good gifts. So just keep that in mind and give my shop some patience if things are delayed by a week or two. But like I said, we'll hopefully have everything beefed up and ready to go for the holiday season. They're trying really hard. They actually got a couple new people working for them, even just to keep up with their online stores that they run. They only run like 3 stores, and they're just getting absolutely slammed right now. So yeah. Let's see. Let's finish up a few more of these questions here. Base 3 do. I really want to mine a comet. That would be awesome. Yeah, I think some days asteroid mining and comet mining will be an actual industry. Mark my words. Oh yeah, sorry, I should have mentioned everydayastronaut.com/shop. That's how you get to my web store. For those of you asking, yes, everydayastronaut.com/shop. Free domestic shipping on orders over 100 and discounted international shipping on orders over 100, because I know how expensive international shipping is. Sorry, these are just the quotes that USPS and UPS and FedEx give us. Like, it's all automated. Yes, I know it's expensive. I'm sorry. Yeah, so that's why I discount them. So yeah, hopefully that helps. I actually take a hit on shipping when you guys order more than $100 worth of stuff. So, because I just want to try to help offset that cost, because I know how expensive it is. Okay. Renaud, just wondering, do you think Starship Mark 1 will actually launch by the end of 2019? I actually do. I kind of do think so. I wouldn't be surprised if it gets pushed to like early December, but I actually do think Mark 1 will fly this year. I think it's going to be kind of doing a bunch of test stand testing this month, but there might even be a chance it flies at the end of November. Who knows at this point? So huge fingers crossed. I got to cover it. I got to go down there. That will delay all videos basically if I'm going down to see that thing fly, but I have to see that belly flop reentry in person. It will be insane. So, yes. So I kind of hope it happens soon. Eric, look up Isaac Arthur. He does have a really good video about space elevators. Yes. And I would need to follow up and do my own video about space elevators someday too. Yeah, thanks, Eric. And Marcus, cool channel. These live chats are always full. Thank you. Thank you. Yeah, if you guys want more exclusive live streams, this will be a good segue to my outro. If you want more exclusive live streams, I owe a huge thank you to my Patreon supporters. Patreon, you guys are the reason why I'm able to make high quality videos, because I don't stress out over making just tons of filler videos. I care so much about the quality of videos, the factual accuracy, the animations, the actual 4K videos, the sound, everything. I care a lot about quality. Quality matters to me first and foremost. And the reason I'm able to invest myself into that is because of my Patreon supporters. So if you want to help me do what I do, including all my video stuff, but also going down and covering things like Starship and Starhopper, and going to, launches to cover those occasionally and stuff like that. Consider becoming a Patreon member by going to patreon.com/everydayastronaut. That really means the world to me. You can also join our Discord channel where you can see, you can hang out with us a lot. I'm in there quite a bit. Hi guys. And, yeah, Discord. And we also do exclusive live streams too for Patreon members. So keep that in mind if you want more. I've been playing Kerbal normally when we do the monthly live streams. So yeah. All right, guys. Yeah. Bro Gaming says, can I use your music for my videos? My answer to that is, if you're a small creator, use my music for free. Absolutely have at it. Just do a on-screen credit and put a link in the description to everydayastronaut.com/music. That's my gift to you, to encourage you to make content yourself and to, work on education stuff or rock climbing videos or surfing videos. I don't care. Use it. Have fun. If you're using it for business purposes, though, then do hit me up so it's the proper license. But if you're a small creator, that's my gift back to you and the community. Absolutely. And speaking of, I'm finally working on getting more music out. 27 Merlins is actually getting mixed and mastered as we speak by a legit producer. Thank God. And now that hopefully I'll have a good working relationship with a new producer, and I'll be able to just start cranking out all those other songs that are in my back library and get them sounding top notch and ready to go. So stay tuned. There will be more music. So, all right, guys, thank you so much for hanging out. It's been fun. I'm glad we had a successful launch. So congrats, Northrop Grumman. Congrats, NASA. Hopefully all you astronauts up on the International Space Station are ready for some fresh cargo. All right, that's going to do it for me, guys. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Bye, everybody.